Hello everyone. In the next couple of video I'm going to focus on text files. But why text files are important? Why we should talk about them in Python? Let's look at an example. So let's say I want to write a function that finds a list of numbers that are divisible by 5, all right? So the first thing that I'm going to do is I'm going to create my main function, so def main, and then let's have a print function. So I only have one print function inside my main, and if I want to basically go inside main function, I need to call it. So I need to invoke that function, and the way to do it is having the name of the function, parentheses, and if that function takes any parameters, you are going to pass some argument to it. If not, you just leave the parentheses empty. All right, now if I run this code, I should see the the line that I have inside main. Alright, now I want to create a list of number and then send it to another function, and in that function I want to find what values in that original list are divisible by 5. To do that, I'm going to import random module to create a list of numbers. All right, so then I'm going to say, all right, create this num list, and in that I want to create a range of numbers from a random number to a random number. So I'm going to say rand int, so that means an integer value, random integer value from 1 to 10. So this is going to give you one random number between 1 and 10. So this is your first number in range. And then for the second number, I'm going to do a similar thing, but I'm going to put different values here. I'm going to say from 200 to 150. All right, so this is going to be your start value, which is a random integer from 1 to 10, and then your end value is another random integer value from 200 to 250. So if we just do this, num is not going to be a list. And let's take a look. So if I say print nums is just going to be a range type. Okay, so if you want to create a list out of that, you need to say, okay, I want to create a list and convert this range variable to a list. So now if I do that, I'm going to get a list. All right, and you see it starts from a random number from 1 to 10. In this example, it started from 3, and then it ends from random number between 200 and 250. If I run my program one more time, I'm going to get a different value. Okay, so in this example, it started from 10 and it ended at 214. All right, now this variable nums is a list that I'm going to send to another function. So let's create another function. I'm going to call it divisible by 5. It takes one parameter. So I'm going to pass num, or you can change its name if you want to. You can call it list or whatever you prefer, because this is a name, this is a value that you're sending. However, when you're working with list, it kind of doesn't matter, because again, with list you're pointing to the same location in the memory, and if you even have a different names, you are changing the values inside that list because it's a mutable data type. So I'm going to go with num list. Okay, so now I have my num list. I want to first see if I can have access to different values that exist inside num list. One thing that I can do, I can simply say print num list. All right, so I'm going to take the print out from here, and if I run it, I'm not going to get anything. Why? Because I never, like, I'm calling my main, and in main I'm creating a list of numbers, but I'm never sending this list of numbers to my function. All right, so to do that, I need to call that function, and then I need to send my list to it, right? So now if I do it, I'm going to see the list that I have. But as you see in this example, the list, you see the entire list as one object. What I want to do, I need to go inside that list, take each of the items and see if it's divisible by 5, right? For that, I need to access each of the elements one by one. All right, so that means I need to have a loop. I need to traverse over this list, take each of the items. So that is going to be the first thing that I'm going to do. I'm going to create a list. Since I have a sequence, it is easier to have a for loop. So for I in num list, which is the name of the list that I have, and I'm traversing over items, not over index number. And now if I say print I should get each individual item in that list. Okay, so now my next step is going to identifying the numbers that are divisible by 5. So I'm going to put a condition. I want to see if an item is divisible by 5. If an item is divisible by 5, and that is when you say if, that means you have a condition. So if my I, which is my current item, is divisible by 5. If it's divisible by 5, the result is going to be 0. Okay? If the item that you have, if you divide it by 5, and if the remainder of that division is 0, that means that item is divisible by 5. So that is when I want to print the item. If I do that, I believe that I only get the numbers that are divisible by 5, such as 215, 220, and so on and so forth. Okay, so let's run and see what we get. So here we go. So 5, 10, 15, 20, 25, and only the items that are divisible by 5 are visible now. But I wanted to find a list of numbers that are divisible by 5. Okay, that means I need to create a list, a new list. So I can say lst equal to empty, so it starts empty, and then as soon as I find that item, I'm going to append it to that list. So I'm going to say lst append, and then I'm appending that I, which is divisible by 5. If I do that, and after I'm done traversing over all of the item, that means the for loop is terminated, I'm going to print my lst. Then you're going to see one list of all of the items that are divisible by 5. You can either, if it wants you to return that list, you can simply say return lst. If it wants you to print it, you print it. In this example, I'm just going to print it. All right, so now I created that list. Imagine you have big numbers. Okay, imagine this is not 200 and it's 2 million. All right, so you're creating a huge list of numbers, and the reason to do that is it is hard to do it manually. So you use a program language to do the calculation for you and give you the result of some calculation. However, if I close this program now, I do not have access to the output anymore. The output that I created is only accessible to me as long as this program lives, right? If I close this shell, I do not have access to that data anymore. All right? But in real life, we produce so much data that needs to be stored, so we can use them outside of the program life, outside of the span of its life. So the way to do it is by using text file. So for instance, I created a list here, and I can simply use Python to write that list into a text file. All right, then if I close my program, I have access to that text file. It's similar to any other text files that you have. You can simply open that text file and read the information. Another case is, let's say you have a data that exists already and it's in the form of text file. Okay, so let me open it for you. So let's say I have I have a text file that has name of fruits and vegetables, right? Let's imagine this list is like a huge list, and it could be numbers, it could be anything that you want to store in a text file. You see the extension is .txt, so it's a text file. I can open it. I do not need to have Python program in my computer to be able to open that. It's just a simple text file. So let's say I have some information here. Let's say I have the name of a students, their last name, their 850 numbers, and they are all stored in a text file. And I want to process that information using my Python. I want to see how many people that I have in my list who are called Sarah, right? So if I have a text file, I should be able to transfer this data into my program to be able to process it. Then that becomes another application for text file. Sometimes you want to read from a text file, sometimes you want to write into a text file, all right? To have access. Sometimes you have access to data and you want to process that data. And sometimes you're creating a data set and you want to store it in a text file so you have access to that data outside of your program. So as we talked about, we can create different data sets, different data structures inside our program. But as soon as you terminate your program, those data that you created are not available anymore to you. So if you want to save your data in a way that is accessible outside of your program, you should be able to there should be a way that you can store your data in a file, and then you can have access to it from one program to another. There are different ways I can store your data into a data file. In this chapter, in this semester, we're only going to talk about text files. A text file is a file containing characters structured as lines of text. Text files always contain a non-printing new line character at the end of each line. And text file can be directly viewed and created using a text editor. You don't need to use Python to do that. You can directly open them outside of your program. There are four fundamental operations that we have on text file. The first one is you need to open a file to have access to it. So opening a file is the first step when you're dealing with text files. And whenever you're opening a file, you always need to close it after you're done. Okay? So opening and closing, you must have both of them when you are dealing with text file. Then you are either reading from a file or writing to a file, depending on what you want to do. And sometimes you're reading from a file, you want to change it, and then write the change data into another text file. Again, all files must first be opened before they can be read from or written to. So in Python, when you open a file object is created, and that is why it is important to close the file after you're done processing it. The way to open a file is very simple. You use keyword open, right? Open a file, the keyword for it, the function for it is open. So similar to any object that we created in Python, like for instance integer object, a string object, list object, we need to give like and associate an identifier or a name to that object. So for instance here, the name of the variable that I created for that file is input file equal to, and then you're trying to open a file. So keyword open or function open, and it takes two arguments, all right? The first argument that you have is the file name to be opened. What are you looking for? So you put the file name and you see you have the .txt extension because we are trying to open a text file. And then the second argument depends on how you want to open that text file. Sometimes you want to open it only to read from it. Sometimes you want to open to write to it. Sometimes you want to open to read and write. But we are only focusing on reading and writing only. So in this example, I want to read from this text file, so I use R. If the file is successfully opened, a file object is created and assigned to the provided identifier, which in this case we are calling input file. If you try to open a file that doesn't exist, you're going to get an input output error, something such as this error message. It says no such a file or directory, and I'm going to show you an example in a second. Later in this chapter, I will talk about how to catch those kind of input output errors, so we know what exactly happened when we receive that error. Instead of crashing the code, we can handle those kind of error messages. Here is the program that we wrote to show that when we can create some data set, and after we done after the program is terminated, we cannot store or see the data anymore. So we want to use textfile to be able to store the data. So for now, let's just try to open a text file, because if you want to store something into a text file, or if you want to read something from a text file, the first step always should be to opening that text file. So let's do that. So I'm going to create input file, which is my identifier. That's the name that I'm giving to that file object. And then the keyword or the function open, all right? Open close parentheses, and function open always takes two arguments. The first one is the name of your text file, okay? I'm going to say Sarah, for instance, sarah.txt, comma, and I want to read from it. Okay, so I want to read from this text file. I go all the way down, and before I forget, I make sure I close this text file. So input file dot close, and as simple as that. Okay, so I opened it here, and I'm closing that text file right here, because after you're done, you already created a file object in this line. And if you do not close it, you're going to see some problems with that text file. So make sure always close it. So remember, opening and closing, these should be your first two things that you do when you're dealing with text files. Okay? Very simple, open and close. All right, now let me run this program. This text file does not exist. I do not have any text file that is called sarah.txt. So if I run it, I'm going to get that error message. It says no such a file or directory as sarah.txt. This error again happens because that file name is not found in the location looked for. And just be careful with the text file names. Uppercase and lowercase letters are treated the same for file names. So if you have uppercase sarah.txt versus lowercase sarah.txt, they're exactly, Python sees them as same thing. So when you open a file, the first folder that Python looks for that file is in the same directory, in the same folder that your program resides in, right? For example, my program is this one, lecture 1, and it is in this folder for lab for week 9, all right? In this folder, I do not have any text file that is called Sarah. Because of that, I'm going to get that error message, because this is the first folder that Python is going to look for that text file, and if it doesn't exist, you're going to get that error message. You can also give an alternative location to open a file. So you can give it a path to a file. You can say, all right, you need to find that folder or that file in this folder, which is called data, and then you're looking for this file name. So let's see how we can do something like that. So if I go and create a folder and call it data, for instance, and then inside data, I'm going to create a text file and I'm going to call it Sarah. So text file sarah.txt, and if you want, you can store some values in it. So I'm going to say line 1, line 2, line 3. Okay, I'm going to save it, close it, and then go back to my program. So as we saw, my program is lecture 1. The Python file that I have is called lecture 1. And in this folder, as I have my program in, I have another folder which is called data. Inside data, I have this text file that is called Sarah. So now if I run this program again, I'm going to get the exact same error message, because still Sarah does not exist in the same folder as my program. It exists in another directory. All right, so if you want, you should give the exact path. So it's going to be data slash Sarah, and you can run it and you see no error message. That means it found that text file. This is called relative data path because it is relative to the location of your program. Okay, wherever your program resides in, it is relevant to that location. So you're saying wherever this program is, there should be a folder called data, and then inside data, you're having this text file. Okay, so it is relevant to the location of your program. On the other hand, you can give it an absolute path. You can say where to find that program, and we can do it. Okay, so let's take a look. The easiest way to do that, you can go up here, just copy this path, and you can directly put it in your Python program. So after I copy that, I can paste that path right here. So Control V. One thing that you need to change is you need to change all of these backslashes to slash. Otherwise, you're going to get an error message or syntax error. So it's tedious, especially if you have a very long path. And then at the end, you put the name of your text file. So for me, it is in folder data, and then in that I have sarah.h, right? So if I run it, not .h, .txt. I don't know why I put .h. Here you go. All right, so it was able to find that path or that file, and that is called absolute data path. So depending on what you need and where your data is stored, you can use either absolute data path or relative data path. And again, when the program has finished reading the file, it should be closed. And you can do that by just simply putting the name of your file object and then period, close, and parentheses. Once closed, the file may be reopened by the same or another program. Every time you open the file for reading, it will start again at the beginning of the file. Okay, so and that is very important information, very important thing that you need to understand. So every time that you're closing a file and reopening it, it always starts from the beginning of the file. So now let's start storing some information inside a text file and be able to see that text file using a Python code. So I'm going to create a text file and I'm going to call it data. So to do that, you right click if you have a Windows machine, you go to new and then text file. So, and then I'm going to call it data, and you will see the extension .txt, right? You can open that text file and store your information in it. So line 1, line 2, and line 3. Save it, and let's see if we can read this file. Going go back to my program, and here I'm going to have data.txt because this data.txt exists exactly in the same folder as my program. Okay, so this is my program and this is data.txt, so I can directly call it. So if I run it, I should see that it was able to read that file without any errors.